Hey everyone, I am Bhupalan Jayaraman. I work as a technology solution architect. I welcome you all to the discussion of the project Athena. I take this opportunity to thank Tiger Graph, the panel members, and the fellow participants. It's amazing what you guys are doing here. Okay, let's get started. In one sentence, Project Athena is a generic knowledge graph framework that builds itself, speaks your language, and blends with existing tools. A staggering estimate says 80 to 90% of data collected by organizations are unstructured data. Making sense of unstructured data is difficult. But what if there was an intelligent system that automatically understood entities and relationships among them automatically from the data? And what if it allowed us to search and query the data using natural language? And what if it was domain agnostic? Well, Athena aims to solve all of that. It's an automatic generic knowledge graph framework that builds itself from textual unstructured data and uses plain natural language to query the data. Consider a month ago, you wanted to know the companies that had some exposure to Russia, directly or indirectly. Directly, you may know a few names already, but indirectly, only a graph can answer that. Athena starts by understanding the domain of the unstructured data, extracting entities and people and relationships among them through NLP algorithms. And then it goes on to build the knowledge graph based on what it understood. In the process, entities become the vertices, whereas the verbs become the edges. Let's assume now you want to query the knowledge graph using plain natural language. Athena applies the same thought process to the natural language query as well. It starts by extracting the entities, finds out the relationships, parameterizes them, and then translates it into an intermediate language using an artificial neural networks model called sequence-to-sequence model. The output of the model is further converted into graph SQL, which is used to fetch the data. Let's try to create a graph now. As we can see, I have only one graph here as of now. Let's switch back to the application and try to create a graph from there. I'm on the generate graph module, and this is the configuration. I have given a new graph name and create graph is set to true, and this is going to read from this input data set. Let's hit run. From the log file, we can see that it started creating the graph and it started creating the relationships and the entities. Let's take a look at the Graph Studio again now. We see it has created a graph. And it already started creating some entities and relationships. Now we are training the sequence-to-sequence RNN model that helps us to convert plain natural language user queries into GSQL queries. This is the input data set on top of which the model is currently training on. On the first column, we have templates of possible questions in terms of natural language. On the second column, we have what we call as intermediate language queries. The model takes these as inputs and output these, and from this we can easily convert this format into GSQL formats. Now we have executed the third module, the NLP graph querying API, and hosted it as a Flask service. This can actually take in plain natural language questions as input, and using the model we trained, it can convert them into GSQL and give us the output. Let's see it in action. That brings us to the end of the demonstrations. Thank you everyone. Have a good day.